This problem is a one sample t-test, right? So you have a sample from this guy, 35 rhinoceri. Their average weight was 4,527, and the stated weight, the claim, was 4,500. Okay, so you're going to set it up like this. You always start with the null. So the null states that the mean weight of all rhinoceri is 4,500, but he's saying it's greater than. Let's check that. Okay, so his average was larger. It's 4,527. Plus, he states that it should be greater than. So whenever you see the word greater than, more than, you're going to subtract whatever your final p-value is from 1, because that's the way everything's set up. But let's go ahead and run through this. So the null is that the rhinoceri weigh 4,500. The alternative is that it's greater than. We're going to go ahead and run it through the Z formula. I filled in all the blanks.
Oh, hi.
That was my grandson. Okay, so you do all your calculations, and you come up with a z-score of 1.38. So you look up a z-score of 1.38. Give me a second.
Hi.
Oh, hi. So 1.38. So a z-score of 1.38 creates a value of 0.9162. But remember, that's everything to the left of that number. Everything to the left. We want everything to the right. And since it's a greater than problem, that is a very, very common error. But just remember, whenever the alternative hypothesis is a greater than, you run it like a regular one. You find the p-value, but you got to subtract it from 1. That's the only other difference. So when you subtract, you get a final p-value of 0.0838. And I believe that is the answer. Yes, that is the answer. So remember, last time, if your alternative hypothesis is a greater than problem, subtract your final p-value from 1. That's it. MGZ out.